Copy and complete the following table of atomic electronic configuration of elements. The elements are A, B, C, atomic number, relative atomic mass 14, 24, 23, 20, 37, number of protons for B is 11, number of neutrons, electronic configuration for C is 1s superscript 2, 2s superscript 2, 2p superscript 6, 3s superscript 2, 3p superscript 5. From what you got, element in A, the atomic number is 7 because the relative atomic mass is 14. Then the number of proton is 7 because relative atomic mass is the product of atomic number and the number of protons. So you have a relative atomic number as 14. The number of neutrons is 7. Then the electronic configuration is 1s2, 2s2, 2p3. For element B, the atomic number is 11. The relative atomic mass is 13. And the number of protons is 11. Number of electrons is 12. The electronic configuration is 1s2, 2s2, 2p6, 3s1. The element C with an atomic number 17, relative atomic mass 37, the number of protons is 17 and the number of neutrons is 20. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 2p5. Arrangement of electrons in an atom. The way electrons are arranged in an atom is determined by the order in which the subshell occurs on a scale of increasing energy level. This is so because in the ground state, the electrons will be found in the lowest energy level available. In hydrogen, which has an atomic number of 1, the electrons must occupy the 1s sub L level. The number indicates the principal quantum number and the letter the subsidiary quantum number. In the case of hydrogen, there is only one electron in the subshell, so we denote it as 1s1. To keep a check on the spin of the electron, we use an arrow pointing up, that is indicating that to show an electron with its spin in one direction, and the arrow pointing downward, that is to show an electron with an opposite spin. Thus, the distribution of electrons in hydrogen atom is shown pointing pointing down, that the element orbitals and electronic level. So you can see the first box having the S arrow pointing up, this S2, no, there's nothing in S2 and there's nothing in S, then there's nothing in P, 2P. Pointing downward, that is this arrow, to show that an electron with an opposite spin. Thus, the distribution of electrons in hydrogen atom is shown below. This orbital diagram, the element hydrogen, orbital electron 1s, electronic sublevel. The electronic sublevel, the arrow pointing upward is first filled. The atom of the next two elements, lithium and beryllium, have 3 and 4 electrons respectively. Since the one orbitals is already filled in the two orbitals, orbital diagram for the element is as follows. Element lithium, orbital electron 1s2, 2s1. Electron sublevel. The electron sublevel, the arrow pointing upwards is first filled for the 1s2 and 1s1. Then the orbital, since 1s2 s has for 1s2 has to be completed, then the downward arrow is now filled. For beryllium, for barium, 1s2 orbital electrons is 1s2, 2s2. The electronic configuration, electronic sublevel, the arrow pointing upwards is first filled 1s and 1s2 and 2s2. Then the downward arrow, since the s is 2, the downward arrow is now filled, which is 1s arrow pointing downward and 2s arrow pointing downwards. Elements: boron, orbital electrons 1s2, 2s2, 2p1. Electron sublevel, the arrow is first filled. The arrow pointing upwards is first filled, that is 1s1, 2s, 2p. Then the arrow pointing downwards to indicate that 1s2 is completely filled, 2s2 is completely filled. Since the 2p is only one, then there's no, the arrow, the electron sublevel is complete. For nitrogen, orbital electron 1s2, 2s2, 2p3. Then for electron sublevel, the 1s, 2s, and 2p is first of all filled completely with arrow pointing upwards. That is 1s, 2s, 2p. Then since the p has 3, since the 2p has 3, then the p has to be 3. Then followed by, since the 1s, to complete the, it has 2 electrons, so then the arrow pointing downwards is now to indicate that S is completely filled. Then for fluorine, we have that the element is fluorine, the orbital electron is 1s2, 2s2, 2p5. The arrow pointing upwards is first filled for 1s, 2s, 2p. Then followed by, since the arrow pointing downwards is to show that it's complete electron in the shell, you now have 1s will now be complete, 2s will now be complete. Then the first box in the 2p is now filled, followed by the second box with the arrow pointing downwards. Once it is, we have completed the 5 electrons, then we stop. Element carbon,